Hi, ladies and gentlemen of trigonometry. Mr. Heeren coming back at you with one more little piece about for two, and this is specifically for conjugates. And conjugates, if you've heard that word before, it has been brought up in algebra two and in pre-calc world. And a conjugate just means if you have like the exact same thing just with a different sign. So if you had A plus B, the conjugate would be A minus B. And the reason for that is the reason why you would do that or why you would have that is like if I had A plus B, I want to multiply by A minus B because that's going to give me this. Okay, if I wanted that for a denominator or something. So I want you to realize that you can use these with proving basic identities or with solving basic identities. So if we look, I look at cotangent squared x minus cosine squared x over tangent squared x. So cotangent, remember, is just going to be 1 over tangent squared x. And then that's just going to be minus cosine squared x over tangent squared x. So here I've got common denominator. So that's going to be all over 1 tangent squared x. I'm basically essentially turning it from two fractions into one fraction. And then this, I have to remember sine squared x plus cosine squared x equals 1. And then a little maneuvering, I can rewrite this as sine squared x over tangent squared x. So now I'm making it even simpler. I'm going to go a step further and say, top is sine squared x. Tangent rewritten is sine squared x over cosine squared x. So I've got fraction within fraction. I know I made it a little more complicated, but I did that to make it significantly simpler in the long run. So I multiply both the top and bottom by the very bottom by 1. So that cancels out. I'm left with sine squared x cosine squared x all over sine squared x. So that cancels out, that cancels out. I'm just left with this. Okay, so after all that, all I end up with is cosine squared x. Okay? So now if I take a look here, this is where I'm going to want conjugates, what we were talking about before. So I want 1 plus sine squared x. But whatever I do to the bottom, I have to do to the top. So I'm multiplying this by 1. This is why I can get away with this. I'm basically multiplying by a version of 1 to both sides. So on this side, I want 1 minus sine of x and 1 minus sine of x here. Okay, so what's that going to do? That is going to make the top 1 minus sine of x plus 1 plus sine of x. Sorry, those should not be squared. Those should just be regular sine of x. Over, then when I multiply these together, I end up with 1 minus sine squared x. Okay, on both of them. 1 minus sine squared x. So it's a common denominator, so I put it together. So I get 1 minus sine squared x. And all I did was, some call it FOIL, some call it double distribution, whatever you call it, you got to multiply everything together, but realize that the middle term is going to fall apart. All I'm left with is that. So now a little simplifying, minus sine x plus sine x cancels out, so I'm left with 2 over 1 minus cosine squared x, all right, because I can rewrite that. So that's going to be 2 times 1 over cosine squared x. So rewritten, that's the same thing as 2 secant squared x. Okay, but here's kind of the key point. Multiply by whatever that is, just the opposite sign. Okay, so this one, don't get too distracted by cosecant. And this is one of those times where you don't want to try and start building a fraction within a fraction, because you're going to just be in a whole world of trouble. So I want cosecant minus 1, cosecant of x minus 1. Over here, I'm going to have cosecant of x plus 1 to both sides. Both top and bottom, sorry, not both sides. So I'm going to end up with cosecant of x minus 1 minus cosecant x plus 1 all over, and when I multiply these together, I get cosecant squared x minus 1. Okay, when I multiply these together, I have cosecant x minus 1, cosecant x plus 1. Multiply those together, double distribution. You end up with cosecant squared x minus 1. Okay, so what happens, I take this negative through, minus cosecant x minus 1. That cancels out. I'm left with negative 2 over cosecant squared x minus 1. All right. So cosecant x, this is where I'm going to deal with cosecant x squared minus 1 on the bottom. Because this is going to be kind of a tricky one, just because that's going to be 1 over sine squared x minus 1. So all I'm going to do is kind of rewrite this with a common denominator just in the bottom. Okay, so what that does is that gives me 1 minus sine squared x over sine squared x. But remember, this is just going to be cosine squared x over sine squared x. Okay, I'm just rearranging that. Okay, so let me back up and see what we got here. I know there's a lot of pieces to this one. So far I'm here. All right, but again, I got a fraction with a fraction. I don't want that. So I'm going to multiply the top and the bottom by the reciprocal of the bottom. So that cancels all out. So now I get negative 2 sine squared x over cosine squared x, which is a fancy way of saying negative 2 tangent of x. Okay, I know that was a hard problem. And that was probably the hardest one you're going to see, or anything like that. But I just wanted you guys to be aware of it. These are not normally used as a conjugate, but they do show up, so I want you guys to be aware of them. All right, part 2 of the worksheet. And then we'll talk more about these. I'll walk through some of them with you during class. On the third page, just